Now we will see, if I make any changes in the circuit, how the matrix relation will be affected. So directly we can able to understand. Now we are in the stage to write this matrix form, or the conductance matrix, which is in product with column vectors like node voltage vector and source vector. That means here we can write v1, v2, v3, and it is equal to two sources are there here, i1, 0, and i2. This is what we know. So we can write this particular matrix relation directly by observing the given circuit, which is containing independent current sources and resistances only. Okay, for that only we are discussing all these points. Now if I make any change, okay, in the circuit, then how this relation, how this matrix relation will be affected, that is what we have to see. Okay, so it will be very interesting. See carefully. If I take one new resistor in between node 1 and 4, and this one I am taking as RA, then what will happen? Actually, this G11 plus G12 is related to node 1 only, but now node 1 is with RA also, so correspondingly we will get a conductance GA. So actually these diagonal elements are related to the conductances which are directly connected to node 1, node 2, node 3. Now RA is directly connected to node 1, so that here we will get plus GA. Okay, and do we get any other changes? It is not connected to node 2 and it is not connected to node 3, so this is the change we can able to tell. Okay, now further what I will do is I will take one more change, then how it will be affected I will tell. So just I will erase the changes what I made now. Now the new change is nothing but I will take another resistor which is from node 1 and node 3. So like this I will take one new resistor, because it is in between 1 and 3, I will take this is R13. And this R13 is directly connected to node 1, so that we will get the first diagonal element is a G13 plus G11 plus G12. But this R13 is also directly connected to node 3. So the third diagonal element will also be affected, that is previously we have G23 plus G33. Now in addition to this one we will get a G13 also. Is it enough? No, because the non-diagonal elements are related to the conductances which are in between the two different nodes. So this G13 is connected in between 1 and 3. So this position will be affected. If this position is affected, because it is a symmetric matrix, so this position will also be affected. So what are the changes we will get here? Because it is the first row, the first row, we'll get the negative. Okay, and third column, that means the conductance related to 1 and 3 nodes we have to see. So that is G13. As per symmetry condition, I can take here minus G13. So these are the changes will be occurring due to the presence of R13 resistance in between node 1 and 3. Okay, now one more change I will make. So before that I will erase the changes what I made in the previous thing. So that we'll get here 0 and here also 0 for this circuit. Now the new change whatever I'm going to do is I will work with now new current sources. So what I will do is instead of taking this I2 upwards, what I will do is I will take here the current source downwards. Okay, I2 is like this now. Okay, one thing you have to remember, this source vector, it is called source vector, which is involving the independent current sources. And as per this one, what we need to do is, it is involving the currents which are injected into the nodes. As per previous diagram, this I1 is the current which is injected into the node 1, into node 2, This is injected into I2 is the current injected into node 3. This is as per previous diagram. So now also I1 is injected into the node 1 only. It is going into the node 1, so that there is no change in I1. So it is correct only. And no independent current source is injected into the node 2. So 0 is also correct. But I2 is not injected into the node 3. It is coming from the node 3 or leaving from the node 3. So how to make it as injected current? We have to take simply minus. So this minus we have to include here, so that minus I2 is injected into the node 3. So this is the change we will get. And the direction of the current source is reversed compared to the previous case. Now this is the change we got. Okay. Then now new change I am going to take. Before going to take the new change in the circuit, I will erase these changes. So this is the actual one. Now again I will be dealing with the current source only. That current source I will put in between 1 and 3. This one I will take as Ix. Then what will happen? So from the node 1, now two current sources are connected at node 1. One is I1, second one is Ix. But I1 is injected into the node 1, but Ix is not injected into the node 1. It is going away from the node 1. So as I1 is injected into the node 1, there is no change in the I1. But Ix is leaving the node 1. How to make it inject? You have to take minus Ix. So like this we have to take. And no current source is connected to node 2. So this 0 is correct only. Now at node 3, Ix is injected, I2 is also injected. I2 is already placed. Ix is injected, so that I have to take here plus Ix. Now this is the modification we will get. One thing you have to observe. When I make the changes in the current sources, only source vector is affected. That is what you need to observe. When I make changes in the resistances or the conductances in the circuit, then conductance matrix will be affected. Okay. So these are the points you have to remember. Now, these are the changes we got because of the presence of Ix in between 1 and 3. Now what I will do is, I will take one more change. Before that I will arrange all these changes what I made here. So for this diagram, this is the matrix relation. Now what I will do is, I will take one new current source, that is in between node 2 and node 1, like this I will take. Okay. So otherwise you can take arrow here. Then what will happen? Again same thing. At node 1, now I1 and Ix are related, but I1 is injected, Ix is leaving, so that I have to take here minus Ix. Now node 2 is with the current source. So Ix is injected into the node 2. So now we will get here, we will not get here 0, we will get here Ix. And node 3 is related to I2 only, that's already there. So these are the changes we will get. Now you see, by knowing this particular concept, this any type of the circuit, okay, you do any modification in the resistance values, you do any modifications in the source values. So accordingly, directly we can able to make changes in the matrix relation, and you can able to find out the results very easily. Okay, thank you.